Hey everyone, welcome to WinHEC Online Windows 10 Fall Creators Update. If you missed our first video of the connection exerciser, please go check it out as well. Phil and I are back again, and now we'll talk about the much anticipated USB Type-C SuperMUTT. This is a tool that a lot of our partners have been asking for, and it is now finally ready. For this video, we'll walk through basic USB power delivery testing with the Type-C SuperMUTT. Ta-da! Okay, sorry, it's just exciting to see this tool come to life. Anyway, Phil, do you want to give a quick intro to the tool?
Yeah, this is the Type-C SuperMUTT tool that we've been working on. If you're familiar with our older SuperMUTT tool, here it is. The Type-C SuperMUTT is the next generation of the MUTT family, and as you can see, it's a little bit bigger than the older SuperMUTT.
Ha, just a tad.
It builds on the foundation of the SuperMUTT by adding Type-C and power delivery capabilities. This enables test and automation scenarios around charging, alternate modes, role swaps, as well as traditional USB host and peripheral data. This device is capable of additional features, but today we'll be focusing on power delivery. This device has two Type-C ports. It's designed for testing PD functionality of a system with the captive cable and testing a charger via the receptacle in the back of the device. First, we'll demonstrate testing the system's implementation of USB power delivery.
So I can test with both regular USB Type-C chargers and the chargers that are PD compliant, right? Because not all Type-C chargers are PD compliant. Although we do want to encourage our partners to support PD in general.
That's right, but today we'll just be testing a PD charger. Just a quick note, we wrote a sample app called samplepdtest.exe to demonstrate the Type-C SuperMUTT's capabilities. When this tool is fully integrated into the MUTT software package, it may end up looking a little different, but we'll have documentation up on our MSDN page. Okay, to start things off, we'll simulate a PD charger and validate that the platform selects the appropriate contract. We'll first send a command to initiate emulation. We'll use the command emulate PD provider and include a list of power contracts to support. You'll have to take my word for it, but these values I'm providing on the command line are valid 5 volt 15 watt and 12 volt 36 watt PDOs respectively.
PDOs are power data objects, by the way. We love our acronyms here.
We sure do, Matt. Now that we've connected emulating a charger, we'll use the getRDO command to read back from the Type-C SuperMUTT which contract the system actually requested. We see that the platform has selected the 36 watt contract as expected. We could script this process with a variety of different charger profiles and validate that the system always selects an appropriate contract.
That's pretty neat. So you can also simulate different types of chargers contracts with just this one tool. That'll be really nice to have instead of having to carry around multiple chargers.
Yep, that's correct. Next, we'll simulate a PD consumer and validate that the platform offers and provides an appropriate power contract.
I see. So you want to make sure that it's not advertising something crazy, right? And that the system is actually providing what it is advertising.
That's right. We can check what the platform advertises, select a contract, and then measure what it actually provides. First, we'll send the emulate PD consumer command to instruct the Type-C MUTT to reconnect as a PD power consumer. Next, we'll read back the power contracts that the system advertised with the get system PDOs command.
Is there a limit to how many contracts a PD-capable charger can offer?
There is. Power delivery supports up to 7 power data objects. This system that we are using today supports the default 5 volt 3 amp contract, but we'll select that now using the select PDO1 command to select the contract at object position 1. Finally, let's validate the voltage sourced by the system using the get system volts command. We see that the system is behaving as expected and is supplying the advertised voltage.
That's great. Can we do the same thing for chargers?
You sure can. Now let's look at testing chargers. We'll connect a charger to the receptacle on the back side of the Type-C SuperMUTT. Now that we've connected it, we're ready to test its implementation of USB power delivery with the Type-C SuperMUTT.
I see. So we want to test that the charger actually implemented PD correctly.
Yeah. As we did with the system, we'll look at the power contracts that it advertises, select one of them, and verify that the charger is sourcing the correct voltage. First, we'll send the command emulate PD consumer to instruct the Type-C SuperMUTT to connect as a PD power consumer on the charger receptacle. We'll read back the power contracts that the charger advertised with the get charger PDOs command. This charger supports 3 different power levels. We'll select the 45 watt contract now using the select PDO 3 command. And finally, let's check the voltage sourced by the charger using the get charger volts command. "14.91 volts. That looks about right. For the sake of time, and we won't do it now, but we could walk through the remaining contracts and validate that each could be successfully entered and that the chargers source the appropriate voltage at each level.
All right, very cool. I think that wraps up our time today. Thanks for taking the time to listen to us talk about the Type-C SuperMUTT today and how we can use it to test USB power delivery. Please go to the MSDN page in the video description for more details on the Type-C SuperMUTT and the most current software and firmware as we add additional features to it soon.
Thanks again, and don't forget to fill out the survey for the session. And happy testing!